Welcome to this webinar. The topic today is framing openings and the use of cut opening tool in Revit and using that together with Agacad software. In this case, or today, it's about metal and wood framing. My name is Paulus. I'm BIM application engineer here at Agacad. Here we specialize in building BIM together. In other words, we create software or BIM solutions for architecture, engineering, and construction industry professionals. We have been doing that for quite a while. The aim is to reduce BIM stress or try to eliminate that as much as possible. In other words, we try to automate workflows, automate the processes in every niche company that come to us. Recently, Agacad had joined European Digital Transformation Leader, that is Aleksandras. So we are now part of a bigger thing, and we established in Europe, in Lithuania, Vilnius, but our client base sort of encompass entire world, to be honest. So we have companies from North America, South America, Canada, Australia, etc., as well as Europe as well. Okay, so the couple of tools or packages we'll be looking at today, wood and metal framing. This is a list of entire portfolio of software solutions that we have on offer. You can go to agacad.com, our webpage, and go on the products, and then you'll be able to look into more detail into every package that you can see in front of you. Okay, so wood and metal framing suites, but we also differentiate those into walls, roofs, floors. All three of those would be part of the suite. So that's something you could have a look if you find it useful. So we've been recognized by Autodesk as AEC industry partner. That's also speaks for itself. Wood and metal framing. So those two tools, briefly speaking, are ideal for distributing structural framing members, producing insulation, sheeting, paneling, cladding, all kinds of elements you would have to produce for a timber or metal frame project. We can produce fixings and details and all kinds of things. We can then create shop drawings, get auto dimensions, and then export to CNC. So that's pretty much the full spectrum from modeling to exporting to your saw. Okay, so looking at the framing openings and the use of cut opening. So cut opening is a tool that's also part of a wood and metal framing packages. What it does, it basically lets you insert openings in the project. So that's based on the clash detection that you perform in Revit. And then based on that information, you would then use cut opening and insert openings automatically. We're also going to look at what kinds of openings wood and metal framing software is able to recognize. Okay, so like I said, a few things. We're going to look at the key benefits of cut opening and wood metal framing functionality, and so combined workflow. Okay, so we're going to perform a clash detection, use cut opening, and look at some parts of the configurations, and a couple of other things. Okay, so let's move on to a live model I have open. So I guess the first thing I would like to pay attention to are the types of openings we can use together with the framing software. So like I said, right at the start, you want to have some sort of model that's detailed enough to begin framing tasks and producing production of drawings. So you want to have levels established, grids, and all these sort of basic things, coordinates, hopefully. And you then want to work out your different wall types, roof types, floor types, and then move on to framing. Things can change, even though if you've framed half of the building or entire project, if things change in terms of how it's framed or how it's supposed to be framed, you can change the framing configurations. If geometry changes, so let's say the wall, some walls become taller or they reduce in length, then you can adapt the framing pretty easily and efficiently. So that's an example of Revit model. There's an example of this model framed. Well, that's not framed yet, actually. Okay, so I'll show you an example of a model that is framed. Before that, one piece of advice. So when you begin working with framing software, a good practice would be to set up a template project in which you're going to place all your families for studs, plates, whether these are wood or metal, and perhaps you're going to want to have your wall types laid out in front of you. You want to test or resolve your configurations per each wall type. So that's something I would definitely consider doing, and perhaps you even want to work out your different roof, ceiling, floor types, wall types, etc. You may want to also have other things like view templates and different kinds of families you want to use in the projects. So something that is company specific or company standards, you want to place that in the template project. Same goes for openings. So if you place all of the types of windows and doors and so general openings you use, that's great. You can come back to those and reuse them. But generally speaking, we can use, so if I make a copy of this wall actually on the side, just gonna get rid of everything but the wall. So as you noticed already, we can change the wall profile, change the slope or the pitch, or change constraints without applying offsets or attaching to levels. You can just do that with manipulating the profile lines. Same goes for openings. So if we draw some sort of opening in the wall, this opening will be recognized by the software. That's a system opening. You can further manipulate. You can also place opening families. So I think Revit 21 and 22 already have ability to access cloud libraries of families. So you can search categories of doors of general openings, like some of them that we have here, and you can place those as well. Of course, doors, door families, window families, generic model opening. We can place those as well. Okay, and we can actually just take a wall and draw an opening like this. Include that as well. Okay, so once you have things positioned, you can begin framing. So let's say the wall layers are worked out, so we know the thicknesses and layer functions. The next thing you would want to do is pull out the wall plus tab or panel and frame the wall. If changes happen to the wall geometry, or maybe you lose a window or a door, perhaps it's just a system opening, then you would update the frame. As you can see, all of the openings have been recognized and framed accordingly. If we go into configurations and navigate to opening framing, we can see we have different categories. So we have windows, doors, opening families, so generic model opening family that is phase-based. You can create configurations for those You can also set up how window-to-window joints will be framed and window-to-door joints will be framed. And those two are based on the width of joints. So if the gap between two windows is 100 millimeters, so you set 0 to 100 to use this configuration, and 100 to, let's say, 200 gaps, we'll use a different kind of configuration. To create more configurations or edit existing ones, you go to Edit Configuration, Save As, and you have trimmers and top-bottom cripples for common joints of two windows in this case. And you can use from 100 to 200 gaps, use different configuration. Similar principles apply to windows, doors, and opening families. So windows, again, instead of a gap, this is the actual width of an opening, width of the window in this case. So all the windows from 0 to 1500 millimeters will use this configuration, and all the ones from 1500 to 1 meter use a different one. Okay, and as you can see, the sort of classification of walls based on structural and non-structural. The parameter that controls that is over here. So whether the walls are structural or not, it depends on whether this is switched on or off. So you can control or classify them that way, and you can add more rules and configurations. So if I go to door, edit configuration, I can see that there are tabs responsible for different parts of the opening framing. So king studs, headers, sills, trimmers, etc. Okay, so that's the idea behind configurations. You base it on the width of opening and then assign a configuration in framing configurations window. You can also edit things by instance. So if I go and modify opening and pick opening itself or any framing member that's in direct contact with an opening, let's say this one, and then the same window will open up, except that in this way you will be editing things by instance. That means for this particular wall and that particular opening that you have selected. So if I want to add additional trimmers or add new trimmers from the top plate, for example, add additional header, I can do that pretty easy. And that's going to update the frame, make the changes based on how you edited the configurations right now, and do that. So yeah, so these are the kinds of openings we are dealing with. So if I get rid of those, get rid of that opening family and system opening family, and perhaps, yeah, so I just left this one. So you can see that there are quite a few changes that happen to the wall in the sense of the wall geometry and things that were hosted but no longer hosted in the wall. We can just simply update the frame and pick up on those changes. That's it. Yes, so these are kinds of openings we're dealing with. Okay. In terms of less usual openings, we have closed that project. Okay, right, so let's move on to the other model. So now, in this model, I would like to highlight the functionality, basic functionality of cut opening. So that's a tool that's part of a wood and metal framing suite. So once you install this on your workstation, you can navigate, find those things through the dock. But if you have them installed, you'll have these tabs up here. So in my case, I'm going to this tab, looking for cut opening, which is over here, pulling this out. Don't be mistaken with a cut opening that's free. It is free, but it's restricted. It has restricted functionality. So if you're using the 14-day trial, or if you have purchased the packages, use the full cut opening. Okay, so I have this in front of me, and probably want to have wall plus, I guess, in this case. All the principles I'm showing, or the logic behind how the tools work, repeats themselves or repeat itself throughout other packages, not so much of packages, other sort of solutions like roof plus, floor plus, for wood and metal. So things would repeat themselves. Okay, so in this model, I have MEP and structural models linked, which is a great feature that cut opening is capable of. So we're going to perform a clash detection, but before that, I want you to just have a look. I mean, we have walls, we have windows, we have doors, and that's our sort of architectural model, let's say. We have MEP and structural linked in. So we probably want to switch them on. Okay, so we know they are positioned in the correct place. They are pinned, which is great. And yes, so now so we have some ducts that are clashing with walls. We have some beams as well. So let's start with ducts. Okay, so if I go to Collaborate tab, go to Interference Check, run Interference Check. In other words, it's like a clash detection that's going to produce a report. So we have a current project on the left. We want to clash walls together with MEP model that's linked to the current one, together with ducts, duct fittings, and ducts. Okay, we're then going to do pipes once we have the framework. So click OK. That's just some clash information, what exact elements are clashing together. I'm going to export this data. So let's say in my main folder where I keep models, I have Agacad opening and the additional folder in which I'm going to export my reports to, and from which I'm going to take those reports and use them. So that's just an empty folder. I'm exporting HTML file, which is good. That's my report. That's done. Then I move on to cut opening user interface. I read interference check data. There are instructions, but you basically need to find the HTML file that exported from Revit. Use that, go next. So now cut opening is reading that report and looks at what items are clashing. Now we save this data as XML file. Okay, that's my old one, but let's say that's a new one. So walls against. Okay. Close that. Then go to Insert Openings, and we need to find the XML file we just exported. Go on Next, and go on Insert Openings. It's auto-joining openings as well. It has 6 openings that were joined, and that is okay. And that is because the openings were so close to one another, so it kind of made sense to just have one unified opening. Okay, so if I now go. Okay, so these are generic model opening families that it has produced for ground and upper floor as well. So these are the clashes of ducts against walls in this case. Okay, now I want to clash my beams. I have quite a few. So again, run interference check data. This time I want to pick walls against structural, in which I have structural framing elements. Okay, export. Let's say we're no longer going to need this. I mean, ideally, you want to probably retain that report, but let's say just going to replace that. Close this. Go back to read interference check data. Pick the file. Next. Save as XML. And now we're going to have walls versus beams. Okay, you can close this. Insert modify. Pick the file walls versus beams. Next. Auto joining. That's done. Okay, so now, the way our beams are made in the link model is that we have floor elements, which we not when clashing. So you either have a floor, sorry, that's a part. So I give it to original. You either have a floor element, which you may want to frame using floor plus, or you don't necessarily have to. So that's a floor element. But also, it has been framed using 3 identical LVL structural framing elements or beams. Well, 3 pieces make up 1 larger beam. So that's how we've done. We clashed walls against structural framing elements, and we got openings. So if I now go back to Revit links and try to switch them off, I can see that so the beam pockets, as you would call it, have been made into the wall structure, and again in the way of generic model opening, generic model family category, openings made in those families. So I've done that, right? So now I guess it would be a good time to frame my walls, right? So good practice is to just double check what configuration is assigned to each wall. Okay, so if I use this frame, and this is a different wall type I've just picked, again, use frame. So I have 2 wall types in this project, and we're going to use same configuration for both, actually. So I can multi-frame or frame one wall, pick all 12 walls, and just go frame wall command. That's going to produce structural framing, and is going to accommodate those openings, because we have actual openings that are cutting wall from interior to exterior. So it's going to look at that and frame around openings based on the configuration it has been assigned. Okay. So if anyone have questions, write them down, and we'll have a look at them right at the end of the webinar. Okay, so that's almost done. It's now basically distributing all the structural framing members, plates, studs, and whatever other families are assigned in configurations, looking at the wall geometry and placing those families accordingly. Okay, so we have framed around all of our openings for beam pockets, for ducts. So those have been accommodated. I guess we can now also switch to see parts and actually switch parts, because I have external layer of sheeting to all of those walls. I can do it one by one, but if I switch to show both, again, select all walls and split parts. Okay, while it's doing that, I can remind you we have eHelp, online help desk, basically accessed via settings, eHelp button. And in there you can download sample projects, look at some videos available on YouTube, and access technical documentation, which is probably the most useful part of all this. And in here you have articles. You can read support ticket if you're struggling with the software, or maybe you have seen a bug potentially. But you can also type keywords like opening framing, wall plus in this case, and it kind of describes in this case how window to window and window to door joining would be made. So this should really tell you all you need to know about window to window and window to door join framing. So that's quite a useful piece of information. Okay, so we have now split parts. Essentially, that's our external layer of sheeting. Whatever the material is, it's always be a different kind of material. If you scroll down, you can see the material that has been assigned, and volume and size as well. Yeah, so we can notice that our openings also are cut in Revit parts, which is great. That's what we want to have. That allows you to fully accommodate MEP or structural MEP services also structural components of the project. So that's great. If I switch to parts and switch on both links. Okay, so what I've not yet done is produce openings for each stud in the frame, where I have some sort of pipes running within the frame. And before I do that, I want to kind of notice that you can produce openings in configurations as well. So you don't necessarily always have to run cut opening or draw openings by hand, like walls, doors, opening families. So like this penetration hole, if you go to configurations, well, in this case, I'm going to modify frame for a quick result. If I go to stud holes, I have a service hole family I'm using. I can change the family size if I wanted to, and I can change how it's arrayed, top, bottom, etc. I can change which base it's going to be located at. But basically, I want to switch this on, and yeah, so have that penetration hole. If that's needed, you can remove that as well. You can change the elevation of that in the context of the wall frame. But I actually wanted to remove one here because I'm going to be inserting openings, so that's this service hole is unnecessary. Oftentimes we use that for more electrical sort of work. So I'm just going to switch this off. Okay, another quick tip. We can also insert details. So if you load sample details, we can add anchor bolts, clip angles, and various kind of details to your frames, because at the moment it looks just quite unfinished. Anyway, so if I now go to, again, interference check data, current project. Okay, so now in this case, not walls anymore, it's our structural framing elements, which we have generated. And I'm going to take MEP pipes, pipe fittings and pipes. Okay, we should have quite a few clashes in this instance. Okay. Now, name this accordingly. Okay, close that. Then go to insert and framing versus pipes. Insert. And it doesn't take too long, as you can notice. You can also apply additional offsets from the pipe face. It can be a rectangular duct, it can be whatever shape your fitting is. You can apply additional offset in this column. So we now have openings in our studs, both levels. So these are opening families, like I said before. You can kind of change the name of that. If I wanted to, okay, so now let's switch off those for a second. Yeah, so openings have been generated, have been framed around, have been recognized. And things like holes in the stud have been also placed. Like I said, I can add those kind of penetration holes, change size of those if I wanted to. I can also look at my structural connections, which I don't have loaded. So if I quickly go and load sample details. Okay, what I could also do is just add details. Okay. You can change how the details should be added based on details configurations. Okay, so what I was going to show you was structural connections, plate cut. So that's a sample detail that you can use. You can use this or specify how it should be used in detailed configurations. I guess it's not hosted on the stud. So basically this can make cuts into structural framing elements, just like we've done this accommodate horizontal pipes. Okay, so that's not. Yeah, so that's the idea behind. So you have to place not on a wall, you have to host it on a framing element. If we do this. Yeah. So you can kind of do things like that with the plate cut family. So not just cut walls, but also cut structural framing members, and so in more detail with that. Okay, so right, so if we go back and show parts, that's our sheeting, and we can go back and switch on our links. Now to delete all openings, that's easy. Delete all openings, that's just one press of a button, and it's going to remove all openings. To sort of adapt, so the parts are fine, so the parts have been, openings from parts have been removed, but the framing is still the way it was. If we want to fully remove an opening, we'll just have to update the frame. Okay, so there's no opening anymore. Okay, so now let's say what happens if things change in your, let's say, MEP model. I hope it's not going to crash. I'm going to try to open my MEP model. Well, that's a central model, so I hope the element IDs will remain the same, but I cannot promise. So perhaps those models shouldn't be central, so it should be just non-collaborative models. Just hoping it's not going to crash. Okay. Okay, let's try, and well, could, just for clarity, switch off structural framing, just have our walls, and let's see what happens if we try to openings revision. Well, there are quite a few openings, so it may take a long time. So ideally, what it would do when you're doing the openings revision, it should catch up with the changes that happened in your linked files, or MEP or structural or any other file, as long as the duct ID remains the same. So you have not created a new duct, existing duct or pipe or beam has moved. You would reload to get the latest version, and you would just do openings revision, and it would scan through all the openings and scan through location pipes, ducts, or beams, and revise the opening. So place an opening in the new position where the duct, for example, has gone to. So that's the idea behind this. And you have also, well, you can join and unjoin openings by hand. So select multiple openings that are near each other, or, well, it should ideally be together or touching each other. Then you can join or unjoin openings by hand. And if you click on this, you'll have configurations. You can export those tables to Excel as well, if that's of any use. Yes, so has now revised openings, and our openings now match the information in MP model. That is, the ducts have moved, so we revised openings, kind of done automatically, and we didn't have to go through all the 3 steps that we typically would have. Yeah, you wouldn't have things like this, of course, but it's a sample model. Now you would want to switch on structural framing, and the framing is no longer matching, so you will just update the frame to pick up on where the opening is in the wall and frame around the new position of an opening. Yeah, so that's that. Okay, so do we have any questions right now? Okay, so we do not have any questions at this moment. I would just recommend to always look at eHelp, what I showed you so far. If you're struggling during the 14-day trial, or you have purchased a license already, well, typically we have 4 hours of training out of a license. But you can always just reach out to us via the email or help desk, and we will be happy to answer all kinds of questions. So if you want to use the cut opening, or you have some less standard sort of opening situations, or kinds of openings that are unusual to what I showed you today, then again, reach out to us and we'll be able to answer your questions. So I think that's okay. So the last thing I want to show you were opening configurations. Okay, so that's not too much about the user interface. Again, getting started should take you to help. So we have families in those sample projects. You have PDF, how to quick start with that opening tool, and getting started videos. So I think that's a great starting point. What are the examples we have here? So is a bit more, detailed projects that we have our clients use, and they have all good words to say about the tool. So in terms of configurations, those are here. So some main settings and where the configuration files are located. You can duplicate, rename, do all kinds of things with configurations. But the main bit is over here. So we're looking at insulation parameters for ducts and pipes, rectangular, round, and oval ducts, pipes and conduits, cable trays, and beams. So all these elements can be sort of clashed with your given information, and you can insert openings. And you can actually add additional sort of parameters like offset from the face, your mark value, minimum width height at which rectangular opening should be inserted, mentioning joining openings, whether you want to join or not, joining shape, outer join, add more rules based on, in this case, beam size, I would say, and yeah, provide offsets and interference check. So with the full interference or partial interference. So whether your item is gonna be passing fully through the wall or partially. So you can switch this on or off. So configuration is not too complicated once you kind of get your head around those. But yeah, so that's an example how you could use wall plus with cut opening, and exactly the same workflow would apply to use cut opening with floor plus, roof plus, or actually entire metal frame package. And you can find this in the doc. Go to all tools or my tools that you have purchased or using trials of. So for example, go here, go to wood frame roof, and I have cut opening over here. So all these packages will have cut opening. Okay, so I think we're gonna end here today. And thank you for coming and having a look at the webinar. The recording will be available in a week or two. And in that meantime, if you have any questions, feel free to email myself. Right, so thanks for joining, and we'll see you in future webinars. Thank you.
Agacad, building BIM together.